the next case of permutations. So we've still got this set of n objects we're going to arrange, but this time they're not all different. In other words, some of the objects are the same to look at. Let's build the cases up to see what's happening with this. So if we only had two objects, now if they were all different, well, two ways, A, B or B, A. Or as we now know it to be 2 factorial. If they were the same, well, there's only one way, AA. I mean, swap them around, you still visually got AA, no difference. So how do we get from 2 to 1? That's the question. Well, do we subtract 1? Do we divide by 2? What's going on here? Well, let's look at 3 objects. 3 objects, all different. There they are, 6 different possibilities, or more to the point, 3 factorial. What would happen if 2 of those were the same? All of a sudden we now have 3. So we've gone from 6 to 3. When it was 2 objects, we went from 2 to 1. So it looks like it's not subtraction, quite possibly it's division. If 3 are the same, well, now we've got one case. So we went from 6 to 3 to 1. So what's going on here? Divided by 2, divided by 3. Let's look at 4 objects. There they all are, 4 objects, 4 factorial or 24 different ways of doing them. If 2 of them were the same, becomes 12. So we go from 24 to 12. 3 of them are the same, it goes to 4. 12 to 4, and obviously if 4 of them are the same, we get 1, 4 to 1. So we've gone from 24 to 12 to 4 to 1. There is definitely a pattern that is happening here. So if we've got n objects, we're going to arrange them, but x of them are the same. Then that's the number of ways we end up arranging them. N factorial divided by x factorial. Now where does it come from? Well, n factorial would be the number of ways if they were all different. We'd have n factorial. What we end up dividing by is the number of ways we could have arranged the objects that are the same if they were different. But because they're not different, then their arrangement doesn't matter. So that's why we're dividing by the number of ways they can be arranged. Let's use an example. Surname of a student from many, many years ago now, but it's a real good one for this example. Knorton. How many different words could be formed using all of the letters in the word Knorton? It would end up being this. There are 11 letters there, so 11 factorial. But some of these letters are repeated. Well, there's 2 O's. So I'll divide by 2 factorial, the number of ways the O's could have been arranged. But there are also 3 N's. So I'll divide by 3 factorial as well, the number of ways the N's could be arranged. So basically we just divide by the repetitions. And I end up with quite a lot of words. What's that? 3,326,400. Let's now look at this HSC one. Because in the HSC they explain everything, assume nothing. So just in case you weren't sure, A, E, I, O and U are what we call vowels. How many arrangements of the letters in the word algebraic are possible? Well, there are 9 letters, and in all of that there are 2 A's. So I'll divide by 2 factorial. There's the total number of words. Well, how many arrangements in the word are possible, hence why they gave us a definition for the vowels, if the vowels must occupy the 2nd, the 3rd, the 5th and the 8th position. Look after the arrangements first. So the first thing I'm going to do is arrange the vowels. There are 4 vowels in there. So 4 factorial. 2 of them are the same. So I divide by 2 factorial. So I've worked out that arrangement and we'll slot them into the 2nd, 3rd, 5th and 8th position. Now we have to arrange the other letters, which of course are the consonants. There you go. So a number of ways of placing the vowels. There are 5 consonants, they're all different, so 5 factorial ways of doing that, and we end up with 1,440, and that will do us. Now we get to play with these sort of ones.